Hello, everyone. We are the Upcycled Phone Sensors team. Here are our team members: Yibo Wei, who is responsible for processing and server management, and Robert Wakefield Carl, who handles the Android application development. Also, we have ChatGPT providing the voiceover. As we can see from the chart, the majority of greenhouse gas emissions for an iPhone X occurred during the production phase, accounting for 80% of the total emissions. This highlights the significant environmental impact of manufacturing electronic devices. Each year, 1.4 billion phones are sold, with an average lifespan of only 2 to 3 years. Yet after use, only 15% of these devices are reused or recycled. This presents a significant opportunity to repurpose old phones, reducing electronic waste and maximizing their utility. We are targeting acoustic monitoring, specifically for bird calls. Previous solutions like Open Acoustics Audio Moth have demonstrated the feasibility of such devices. Additionally, past projects have utilized phones to process data on the device, proving that existing technology can be repurposed effectively for environmental monitoring. Using recycled smartphones offers additional benefits compared to Audio Moth, including built-in GPS and internet connectivity, which enhances data collection and transmission capabilities. Our project goal is to repurpose old phones as acoustic monitoring sensors. Our project consists of two parts: the front end, which is the Android app, and the back end, which is the processing server. The Android application enables the periodic recording of audio data and the uploading of that data to the processing server. Additionally, other sensor data such as battery percentage, battery temperature, and GPS location are also collected and uploaded along with the audio data. A main settings page controls a background service that manages the collection and uploading of data. To enable precise recording times, alarms are set by the background service to start and stop recording. The Enable Recording setting starts or stops the background service. The next two settings control recording length and intervals. Users can select different audio formats based on their needs. The endpoint address setting configures the server connection. The Android app uploads the phone's status and recorded audio data to our web API. The status includes the phone's location, battery percentage, and battery temperature. On the backend server, the audio will be submitted to a job queue system to be analyzed, and the status will be updated in the database. The audio will then be analyzed by BirdNet. And finally, the detected labels will be inserted into our database. Here are some screenshots of the task queue dashboard. And here we have a screenshot of our database. We tested our setup with a home deployment. We installed our Android app on a Nexus 4 and placed it next to a window where bird calls could be heard. The setup recorded 1-minute clips every 10 minutes, and the phone with an external battery lasted about a week. In our test deployment, we collected data on bird species detected. Here are the top 10 most detected bird species. We also analyzed the overall activity of bird species by hour, showing peak activity times. The peak activity time is in the early morning when birds are most active. To summarize, our project involves an Android app that periodically records audio and uploads it to the server, and a backend server that handles audio uploads, processes the uploads, and inserts the data into the database. Next week, we'll deploy our phones. We will also compare the performance of BirdNet with the other acoustic monitoring team's solution. We're also looking into integrating advanced features from Audio Moth, enhancing our model's accuracy and efficiency. Additionally, we're exploring innovative ways to conserve battery life to ensure longer field deployments. Our real-world deployment will kick off soon, allowing us to gather valuable data and refine our approach. Lastly, we're considering a hybrid solution that combines on-device and server processing, aiming to optimize both performance and energy use. For more information and to access our code, check out our GitHub repositories. Dive deeper into our development process and contribute to our efforts in acoustic monitoring technology. Thank you for your interest and support.